Welcome back. This lesson is about functions associated or function associated in quadratics. For instance, if you have, let's go straight away to what we are talking about. For instance, if you have f of x is equals to 5x plus 3, and or you have g of x equals s squared minus 2. You have h of x equals x plus 1 in a root, and you are requested to find the values of f of 1, a, b, g of 3, c, h of 8, d, g root 2. Good. When you have such a function and you are requested to do the algebra, that's how you go about solution. F of x is equals 5x plus 3. Now, where f of x is identical to f of 1, it indicates that x is equals to 1. In that case, I call this one equation alpha. In that case, equation alpha becomes f of 1 is equal 5, x is equals to 1, 5 multiplied to 1 plus 3. In that case, f of 1 is equals to 5 plus 3, 8. That's the answer. Secondly, you are requested that b, g of 3. But given that, g of x has been given to be equal s squared minus 2. Comparing the g of 3 and g of s, it indicates that s is equal to 3, which implies g of 3 equals 3 squared minus 2. In that case, we have 9 minus 2 equals 7. The next one, you see, the C says that h of 8, let's do it here. The C says that h of 8, but we've been given that the function h of x, but h of x equals, oh sorry, this one was plus 1. H of x equal x plus 1, or in a square root. Comparing this one, you can identify it that x is equal 8. In that case, this equation, possibly let's call it alpha as well. It becomes h of 8 equal 8 plus 1 in the square root, which indicates that h of 8 is equals to the square root of 9, which is no different from plus or minus 3. Good. The next one is a g of s equals root 2, where g of s, the function d, the function g of x is giving us s squared minus 2. In that case, when g of root 2 looks like this, then it indicates that x is equal root 2. In that case, let's call this one the same equation alpha, or equation gamma, or equation beta. So in that case, equation alpha becomes g of root 2 equal wherever you see s squared, you put root 2 minus 2. But from indices, you learn that root a times root a is equal root a times root a is equal a. So root 2 times root 2 is equal 2. So in that case, the g of root 2 is equal 2 minus 2 equal 0. Good. Take your time, copy it as we prepare ourselves for the next question. Good, welcome back. We are taking another example. The function f of x is defined by f of x equal s squared minus 2x, where x belongs to all real values. Given that f of a equals 8, find the two possible values for a. Find the two possible values for a. Good. Let's move on. Solution. F of x is said to be equals to s squared minus 2x. Good. Comparatively, f of a would indicate that x is equal a. Good. In that case, comparatively, you can see that s is equal a. In that case, let me call this one equation alpha. In that case, equation alpha becomes f of a equal a squared minus 2a. I'll call this one equation beta. But we are told that in the question f of 8 must be equal to 8. In that case, when f of 8 when f of a when f of a equal when f of a equal 8, then equation alpha becomes, equation beta rather, then equation beta becomes 8 is equal to a squared minus 2a. In that case, we have 0 equal a squared minus 2a minus 8, which implies is 0 equal a squared minus 2a minus a. Then we complete the square. A minus 2 over 2 in a square minus 2 over 2 square minus 8. We have completed the square. Possibly, maybe I was too fast, which I wouldn't like to do, because this is a private tuition and I don't think that there's any good reason to rush, because you've paid for this, so every good service should be given to you. This term, we are going to complete the square, so this term becomes a minus 2 over 2 square minus 2 over 2 square. In that case, that equation there, 0 equal a minus 2 over 2 is 1 square minus 2 over 2 is minus 1 square minus 8. We have a minus 1 square minus, you see, minus 1 square is 1, so it's 1 minus 8. 0 equal a minus 1 square minus 9. So we have a minus 1 square equal 9, which implies is a minus 1 equal the square plus or minus the square root of 9. I think there must be a tiny space here that we can continue. So we can see that we have a equal plus 1 plus or minus 3. Yeah, it's there. Then we have a equal 1 plus 3 equal 4. Is there? Good. Then we have, that is the first solution, and the second solution is a2 equal 1 minus 3, which implies a2 equals minus 2. Therefore, the two possible values of a are a1 equals 4, a2 equals minus 2. Yeah, you see, good. Take your time to copy, and then we will continue by considering the next question. pause the video to go through everything, and then make sure that you copy everything down. Yeah, I think there are some multiple questions that we have to consider. I think from A to C. The first one is this one, but because of the size of the space of the board, we are going to consider them one by one. So you can write the question down as we try to explain the meaning of the question. Find all the roots of the following. A, you can only find a root only when the given function is equals to 0. When the given function is not equal to 0, you cannot find the root. For instance, the given function here is f of s. We can find the root when we put f of s equals 0. In that case, finding the root, we have to put f of s equals 0. So it becomes 0 equals 10 minus 15x. If you watch here closely, it is possible that we can factorize 5 outside. So it becomes 0 is equal 5. Is the question? Yeah. 5 minus 5, 10, it will be 2 minus 3. Good. I think, you know what, let me see. Yeah. So, there should be x. Dividing both sides, of course, you cannot say that 5 is equal to 0. It cannot be. It is mathematically impossible. So all what you have to do is to say divide both sides by 5. If you divide both sides by 5, you'll be left up with 0 equal 2 minus 3x, which is no different from 3x equals 2, which indicate that x equals 2 over 3. So simple question. I mean, you are there. This is basic algebra. And I think the B part was the same. The B part was g of x equals x plus 9 x minus 2. The function, the root, you can only find the root when you put the g of x, the function, equals 0. In that case, to find the root, then the g of x must be equal to 0. In that case, it becomes 0 is equal to x plus 9 x minus 2, which implies this x plus 9 equals 0 and x minus 2 equals 0. From this part, we say that x equals minus 9, which is one of the roots, and x is equals to 2, which is one of the roots. So the two roots are x equals to 9 and s is equal to 2. And the third one, I think, is a quadratic function. Possibly, I will try to write a question. Oh, let's take the time to wipe the board off and then continue. Take your time, copy it, pause the video, and then we'll continue with the third question. The third question, C part, h of x equals to s squared plus 6x minus 4t. For the solution of this equation, you have to put the function equals to 0. In that case, this one becomes 0 is equal to s squared plus 6x minus 4t. Then you complete the square. This square is equal to x plus 6 over 2 minus 6 over 2 square. Then comes the 40. In that case, we have 0 equal to x plus 0 equal to x plus 6 over 2 is 3, and then square minus 3 square minus 40. Good. So it becomes 0 equal to x plus 3 square minus 9 minus 40. Zero equal to x plus 3 square minus 49, which is no different from 49 equals to x plus 3 square, which is no different from x plus 3 square equals to 49. Taking square root on both sides, it becomes x plus 3 equals to plus or minus the square root of 49. The square root of 49 is equals to 7. In that case, x plus 3 equals to plus or minus 7, in which case the first root is x1 equals to minus 3 plus 7, which is equal to 4, and the second root is s2 equals to minus 3 minus 7, which is no different from minus 10. Therefore, the two roots of x, they are 4. The two root of x, the two root of x are minus 10. Good. Take your time, copy it, and we'll take it up from there. Now, here is a question. It says that the function p and q are given by this one. P of x is equal to s squared minus 3x, and the q of x is equal to 2x minus 6, where x belongs to all real values. Find the two values of x for which p of x equal to q of x. This is such a simple question. I mean, solution. P of x equals to q of x will indicate that what is p of x? S squared minus 3x equals to what is q of x? Q of x equal to 2x minus 6. Now, s squared minus 3x, then we bring this 2x to this side. It is positive here, and so when it crosses the border, it is going to become negative. So minus 2x. It is negative. The 6 here is negative. When it crosses the border, it is going to be positive, plus 6 equals 0. In that case, we have x squared minus 3x plus 2x is minus 5x plus 6 equal to 0. Good. This is a quadratic equation. You can either factorize it, whichever way is possible. Let's try to use the completing square approach. S squared minus 5x plus 6 equal to 0. Completing the square, s minus 5 over 2 square minus 5 over 2 square, then plus the 6 equal to 0. Then we have s minus 5 over 2 square minus 25 over 4 plus 6 equals 0. Then we have x minus 5 over 2 square equal to 25 over 4 minus 6. We've shifted this one to the right hand side, and we shifted that one to the right hand side as well. So we cross multiply. This is assumed to be over 1. So cross multiply, it becomes 25 times 1 minus 4 times 6 all over 4. In that case, it becomes 25 minus 4 times 6 is 24, becomes 1 over 4. Therefore, this one becomes x minus 5 over 2 square equal to 1 over 4. Then we will try to take square root on both sides, so it becomes x minus 5 over 2 equals to plus or minus root 1 over 4. Good. So x minus 5 over 2 equal to plus or minus 1 over 2. The square root of 1 over 4 is 1 over 2. So it becomes x equal to 5 over 2 plus or minus half, which indicates that x1 equal to 5 over 2 plus 1 over 2, which is no different from 6 over 2 equal to 3 x1. And the second s2 is equal to 5 over 2 minus 1 over 2 equal to, which is no different from 5 minus 1 over 2, which implies that x2 is equal to 4 over 2 equal to 2. Good. Therefore, x1 is equal to 3, whilst x2 equals to 2. Yeah, then we are done with that. Take your time to copy, and then we'll take the next question. Yeah, this is the next question. It says that the function of f of s is defined as the function of f of s is defined as f of x equals to x squared minus 2x plus 2. X belongs to all real values. E. Write f of x. Write f of x in the form x plus p square plus q, where p and q are constants to be found. It carries 2 marks. Secondly, the B part, which says that hence or otherwise, hence or otherwise. Explain where explain why otherwise. Explain why f of x is greater than 0 for all values of x. And find the minimum value of f of f of x. It carries 1 mark. Well, take your time to copy everything because we will need a whole board to begin to analyze. Take your time, pause the video, and then copy everything that you see on the board. I'll be back with you soon. Good, very good. Now, this was the given equation. The f of x is equal to x squared minus 2x plus 2, where x belongs to all real values of x. Good. And the question says that write f of x in the form of x plus p squared plus q. So this is what we can do. We pick up this term and then complete the square. This term becomes x minus 2 over 2 square minus 2 over 2 square. Then the plus comes there, then 2. We find out that 2 over 2 equals to 1. X minus 1 square minus there's 2 here, remember, minus 1 square plus 2. X minus 1 square minus 1 square is minus 1 square is 1, so we have 1 here plus 2 equal to x minus 1 square x minus 1 square plus 1. F of x Good. So we can say that this equation up there, f of x, which was giving us s squared minus 2x plus 2, is very much identical to x minus 1 square, x minus 1 all square plus 1. I'll call this one equation, equation 5. Good. Let's go back again to the question. Good. We can see that equation 5, do we have a space there? Not really. We can see that equation 5, f of x, which is s squared minus 2x plus 2, is very much identical to x minus 1 squared plus 1, which is very much identical to x plus p squared plus q, which indicates that comparatively p equals to minus 1, whilst q equals to 1. Then that first part of the question is solved, because it said that write f of x in this form where p and q are constants to be found. So the first one is being dealt with. Take your time to copy everything, and then we will shift our focus to the next point, to the next part of the question. Take your time, pause the video, copy everything that you see on the board. In the analysis, we found out that the given function f of x, which is equals to s squared minus 2x plus 2, was very much identical to x minus 1 squared plus 1. Very good. We observe that this part is the symmetrical term, and this one is the y minimum term. What does it tell you? It says that the minimum value can only be equal to 1, which indicates that it tells me that the curve, honestly, it will never cross the x-axis. Why? If you have a curve like this, and you find you have the minimum value to be, let's say here is 1, then obviously the curve, no way it can cross the x-axis. No way. No way. Possibly after this session we may continue the section on discriminant. Okay, let me take the time to explain this discriminant. You can see that f of x ax squared minus plus bx plus c. We find out that a equals to 1, which indicates that greater than 0, which implies is the curve has y minimum. F of x has y minimum because a is greater than 0. We also find that b equals to minus 2. We also find that c equal 2. Good. Now see the discriminant. Discriminant is equal to this. B squared equal to 4ac. What is b? B is minus 2. The square of it. 4. What is a? 1. What is c? 2. We observe that 4 equals to 4. Good. Take your time to copy and we will take it from there. Anyway, this is 8. 4 equal 4 times 1 times 8. Copy it and we'll take it from there. So now, are you convinced that 4 equals to 8? No way. So what can you say? You can say that the b square, which is this one, in fact, is less than 8. Or you can say that 4 is less than 8. Discriminant that says that b square is less than 4ac. This one. If a discriminant says that b squared is less than 4ac, it indicates when b squared is less than 4ac, it indicates that in fact there is no real values of x for which the curve y equals to f of x crosses the x-axis. The discriminant has verified that in fact the curve will never cross the x-axis. And this one that I explained it to you here, this one, the y minimum, this is y minimum being equals to 1. The graph indicates that the curve doesn't cross the x-axis. Good. Hence, otherwise explain where f of x greater than 0 for all values of x. Find the minimum value of f of x. So, in the explanation, every question, we've answered every question. Every answer is being inscribed in the whole analysis. So you can see that the y minimum is equals to this one, while the symmetrical value is equals to this one. So let's try to sketch the graph. You can see that if I may borrow this place, or I'm thinking about the space. Okay, take your time, copy it, and then I'll come back to you again and extend the analysis. These are very important points. I mean, using the discriminant to determine whether or not a curve touches the x-axis, you use this one. A curve will never touch the x-axis when b squared is less than 4ac. It's a condition. It tells you that the curve will never cross the x-axis. Good. Take your time to copy, and I'll be with you. Okay, now let's get on it. Let's get on it. You can see that this is the symmetrical term. At y minimum, the symmetrical term x minus 1 square approaches 0, meaning as y approaches y minimum, the symmetrical term x minus 1 approaches 0, in which case y minimum, for y minimum, x minus 1 square is equal to 0. Or you can say that the symmetrical term is a squared quantity, and therefore the symmetrical term can never be equal to, it can never be negative. At worst, the symmetrical term, which is that one, x minus 1 square, at worst it will be greater or equal to 0. So we pick up the part that says that the symmetrical term equal to 0, and then we find where the symmetry lies. So it indicates that x is equal to 1. This is the equation of the symmetry, or the equation of the symmetrical line. The equation of the symmetrical line equals to s equal to 1, which indicates that the symmetry occurs at where s equals to 1. It is exactly where the curve will be divided into equal portions. Now, you can see that this is how the curve will look like. For instance, jotting down some bullet points, nailing them down. We see that if you watch this equation carefully, or this one carefully, you can see that either this one or this one. On x-axis, or on y-axis, x equal to 0. In that case, y or f of x equal to, when x equal to 0, y equal to 2. On the x-axis, x equal to 0 in this equation. Sorry, y equal to 0 in this equation, y, which implies is 0 equal to x minus 1 square plus 1, which indicates that s minus 1 square equal to minus 1. Taking square root on both sides, we have x minus 1 equal to imaginary, which implies is x equal to 1 plus or minus imaginary. This expression confirms the discriminant that we talk about, which says that b squared, when it is going to be less than 4ac, then it will indicate that the curve will never cross the x-axis. This one also says the same thing. This one says that x is equals to 1 plus or minus imaginary, which indicates that there is no real value of x for which the curve f of x will cross the x-axis. Meaning, the curve will never cross the x-axis. This one also, confirms the discriminant analysis. So we can see that as we are getting close to this specific question, we can see that the curve will be something like this. The symmetry occurs at s equal to 1. And y minimum occurs at 1, y equal to 1. This is y minimum. And then the curve crosses the y-axis at y equal to 2. Then this one says that the curve will never ever cross the x-axis. So using all this information, you can see that the curve will look like something like this. That is the curve of f of s equals to s squared minus 2x plus 2. This should be the curve, and this is the x-axis. Take your time to copy it, and this part of the question is being dealt with. Take your time, copy it, and we'll pick it up from there. Yeah, this is another very nice example. It says that the function of f is defined as f of x equal to 3 square 3 over 2x 3 raised to the power 2x minus 28 3 raised to the power x plus 27 all belongs to, or x belongs to all real values of A. Write f of x in the form 3x minus a 3 raised to the power x minus a 3 raised to the power x minus b, where a and b are constants. It carries 2 marks. Second one, hence find the 2 roots of f of x. Well, this is not a big deal. This one also carries 2 marks. Take your time to copy, and I'll be back with you again. we are let us go through the question again. The function of f is defined as f of x equal to 3 raised to the power 2x minus 28 multiplied to 3 raised to the power x plus 27. The first part, write f of x in the form of this, where a and b are constants to be found. The second part says, hence, find the two roots of f of x. Take your time to copy. Oh, okay, let's move on. Solution. We have here, let solution. Let 3x equal to y. In that case, the left hand side, f of x, and let 3x equal to y. 3 over raised to the power x equals to y. Therefore, this equation becomes f of x. I'll call it f of x at this time because there are some logical algebra. I cannot simply leave this one like that. So I have to negotiate a logical algebra that I can say that if this one is going to be this one, then f of x is going to end. Let f of x being identified as f of, let's say, this one. It's a negotiation. In that case, we have this one equal to 3, but remember, this one can be written as 3x times 2, this one, minus 28 3x plus 27, which is not different from f, this type, equal to 3x minus 28 3x plus 27. But we have wait a bit until the negotiation is enforced. I don't think I have to put this one here. Okay, now let us try to enforce the negotiation. Wherever we see 3x, we will rather put y there, and wherever we see f of x, we put this one there. Now we are going to enforce this negotiation inside this equation. So you can see that we have f of x, the upper dash is equal to we say that this one is equal to y, become y squared minus 28 y minus 27. So you can see that this one becomes a real quadratic equation. I'll call this quadratic equation in y. I'll call it equation micro. Very good. If you are finding the factors of this quadratic equation, as you know, well, 27 minus the coefficient of y squared is 1. 1 multiplied to 27 is minus 1 multiplied to minus 27 is minus 27. Minus 27, we can say that minus 27. No, this one is plus. Sorry, this is plus. Yeah, this is plus, so this should be plus. The coefficient of y squared being multiplied to the constant the coefficient of y squared is 1 being multiplied to the constant. It becomes 1 times 27 is still 27. But remember, 27 is also equal to 27. Let me write it here, but I'll wipe it off. 27 is also equal to minus 1 times minus 27. If I add these ones, minus 1 times minus 27 is the same as 27. If I add the right hand side, I'll have minus 28, which is there. Then it indicates that in fact minus 1 and minus 27 are the factors of the quadratic function. In that case, this equation can be rewritten as, we'll take the other side of the board, can be rewritten as do we have space? No, we don't have space. So it can be rewritten as f of negotiated 1 is identical to y squared minus 27y, sorry, minus 1y minus 27y plus 27. We are trying to factorize y out, so we have y being factorized out. We have y minus 1. The same y minus 1 should be here. Y minus 1. And then this one will be minus 27. So it will be minus 27 multiplied to y, we will have it here. Minus 27 multiplied to minus 1, we have plus 27. So this is correct. So further factorization, we see that this one and this one are common. So we factorize that one out and we have y minus 27. And then we factorize the other one out, y minus 1. Which indicate that the negotiated f of x is equal to this. Let me call this equation tau. Let me call this one equation tau. Very good. Now let's get back to where we negotiated. We negotiated that f of x dash, okay, but f of x dash was negotiated to be f of x. And it was also negotiated that y was negotiated to take place of 3 raised to the power x. Let's try to put everything back again. So we can have f of x is identical to 3x minus 27 3 raised to the power x minus 1. So we can see that this equation is now can now be written as, so the previous given equation f of x, which is 3 raised to the power 2x minus 28 3 raised to the power x plus 27 is very much identical to 3 raised to the power x minus 27. 3 raised to the power x minus 1. Very good. So we can see that this equation is now of this form. Take your time to copy. We'll take it up from there. We'll pick it up from there. Take your time to copy. I mean, everything was done systematically. And you can see that, I mean, the results is very celebrating. Yeah, thank God for such a wonderful analysis. Yeah, take your time. Copy everything. Thank God. Yeah. Now, we have to move on. This was the results. And the second part of the question says that find the root of this equation. You can only find the root of such kind of equation only and if only you put f of x equals 0. In that case, we have 0 is equal to 3 raised to the power 2x minus 28. Oh, sorry. This one is sorry. This one is 28 x plus 27 is identical to 3 raised to the power x minus 27 x raised to the power x minus 1. When f of x is equal to 0, then we are justified to say that 0 is equal to 3 raised to the power x minus 27 multiply to 3 raised to the power x minus 1. Do we have a space? A bit, which indicates that 3 raised to the power x, do we have a space over there? 2 raised to the power x minus 27 is equal to 0, and 3 raised to the power x minus 1 equals 0. When you reach this point, it is nothing different from doing further algebraic manipulations. So it becomes, let me take the time. We pick this one. We have 3 raised to the power x minus 27 equal to 0. It becomes 27. And the other one is 3 raised to the power x. This one, equal 1. So we are solving these two equations. Okay. This portion, to solve the value of x, we have to take logarithm on both sides. In that case, it becomes x log 3 equal to log 27, making the x the subject, so it becomes x equals log 27 over log 3. Using your calculator, you can find that the value of log 27 over log 3. Let's see, how much should that be? Log 27. Do I have it? Log 27 over log 27. Let's use the calculator. Log 27 divided by log 3. Log 27 divided by log 3. Log 27 divided, evaluate, is 3. So you can see that this one is equals to 3. The next one, you do the same thing. It becomes s log 3 equal to log 1. But mathematically log 1 is equal to 0, which indicates that x equal to log 1 over log 3 equal to 0 over log 3 x. X equal to 0. Therefore, the root of this equation is x equals to 3 and x equal to 0. That's it. Then we are done. That was a plausible, it was a plausible approach. And I think that we've done so much. And I will see you again in the next lesson. Have a wonderful day and God bless you.